जो next concept है, that is logistic regression. So logistic regression, what is logistic regression? So let's study that in a bit detail. That is about linear classification. And you need to, what is a linear classifier? Linear classifier means a linear boundary between classes. That is called a linear classifier. So for example, there are two types of dots or circles. One is red. One is red and another is
Sky blue.
blue. Okay. So you need these points are intermixed. You need to draw a liner, a classifier which separate both the classes as with accuracy as much as possible. That is the main aim of a linear classifier. So, for example, this is your your linear data, your data which is distributed in some point. You are given, you plot that, and you with the scatter plot you find that the data is of this shape, and there are two different classes. So you need to find a classifier. The line will might be this one, might be this one, might be this one, might be this one. There are thousands of possibilities, and you don't know which would give you the result with most or more accuracy. So the aim is to find a linear boundary which best discriminate two classes. That is the aim of a linear classifier. Okay. Again, the thing which you hate the most starts mathematics. So linear classifier actually is to find best discrimination. Our best discrimination means minimizing error. Discrimination means that you are not red, don't come in this area, and you are not blue, don't come in this area. So that is discrimination. So best discrimination or minimizing error. What is an error? Error means red dots in blue area is called error, or blue dot in red area is an error. The number of misclassified instances is called an error. So we need a classifier h of x which minimizes this one instance where your classifier h of x is a classifier and yi is your given data label in this term red or blue, where instance I of AB would be, for example, two classes. If A is not equal to B, it means you have correctly classified. But if A is equal to B or a point is in the red line, it means instances there is a problem. Or you represent this with simple difference equation where the classifier could be any value between 0 and 1. If you are classifying two classes, where your label would be either 0 or 1. So in this case, you call a blue a 1 or red is equal to 0, or a red is equal to 1 or blue is equal to 0. Any case. Yeah, it actually represent 1 might represent is equal to 1 when which means that in this instant is correctly predicted or correctly defined. Or this might be in instances in this form or a difference equation or a your squared error function. ठीक है, चले आते हैं आगे इसमें. So a linear classifier means find a line of the best discrimination. For that, you have data points, same as previously in linear regression, where data is represented by 2D, xi and yi, where xi is equal to d points, and y label is 0 between any value between 0 and 1, including that. So our aim is to find W's. Again, this is all about W's, that is weights. So these weights, it will follow you till your last moment if you are in this field. And you need to find the error function where your h of x, which is a classifier, is equal to 1 if a function is greater than 0 or otherwise. और आपको पता है कि जो आपका f of x है वो same generalized equation as previously you have studied. How to solve this? Not easy to mathematically handle because h of x is not differentiable. प्रॉब्लम इसमें क्या है, प्रीवियसली लीनियर रिग्रेशन जब आप सॉल्व करते थे W के लिए, इस पॉइंट को थोड़ा सा आप गौर से सुने. ये आपके पास है, दिस इज योर क्लासिफायर एंड दिस इज योर मॉडल. लीनियर रिग्रेशन में क्या था कि आपके पास एक एरर फंक्शन आता था, उसको आप उसका पार्शियल डेरिवेटिव लेते थे और उससे आप W की वैल्यू निकालते थे. उस वक्त जो आपका एरर फंक्शन था वो एक इक्वेशन था, एक कंटिन्यूअस फंक्शन था. अब जो आपके पास लीनियर क्लासिफायर है, दैट इज एंटी I mean just digits or either binary result, either 0 or 1. So this 1 and 0 is not differentiable, or if h of x is equal to, for example h of x is equal to either 0 or 1. So when you plot this, it could be like this one. For example, this is 0.5 and this is 1. So until this it is 0, and until that it is, so it is like this one. Okay, so this equation is not differentiable. You cannot find the derivative of this function. So that's why it is not possible to solve this equation like linear regression. You need to find another way to solve this problem. This is the main problem of a linear classifier when you classify two different instances. जी ये डिस्क्रीट में है, वैल्यू डिस्क्रीट में आ रही है, तो इसका मतलब है कि डिफरेंशियल नहीं है. डिफरेंशियल नहीं है तो आप पहले आप क्या करते हैं, एरर को विद रिस्पेक्ट टू W डेरिवेटिव निकालते थे, तो आपके पास W1, W2, W3 की वैल्यूज आ जाती है. अब ये चूंकि डिफरेंशियल नहीं है तो इसका मतलब है कि आप उसको उसी तरीके से सॉल्व ही नहीं कर सकते. हाँ, how to solve this? Not easy to mathematically handle because h of x is not differentiable. Simple, clear? No, logistic model actually comes in. जब इस तरह की क्लासिफिकेशन हो तो आपको लॉजिस्टिक रिग्रेशन की तरफ देखना है, क्योंकि वो आपको एक सॉफ्ट फंक्शन देता है इंस्टेड ऑफ अ हार्ड फंक्शन. सॉफ्ट फंक्शन और हार्ड फंक्शन क्या है? तो अगर आपके पास इस तरह डेटा हो, आप इसको स्क्रीन पे नजर आ रहा है कि आपके पास एक्स एक्सिस पे कुछ डॉट्स हैं जिसमें y इज इक्वल टू 0 है और y1 है जिसमें कुछ डॉट है. जब आप इसका लीनियर रिग्रेशन निकालते हैं या लीनियर क्लासिफायर निकालते हैं तो इसके आपके पास इस तरह का रिजल्ट आता है, स्ट्रेट लाइन. बट क्या ये इन डेटा सेट को अच्छी तरह रिप्रेजेंट कर रहा है? क्यों क्यों नहीं कर रहा? क्योंकि ये सारा स्पेस दरमियान में खाली है. तो लीनियर रिग्रेशन से ये मॉडल आपको बेस्ट फिट देता ही नहीं है. आपको एक और फंक्शन चाहिए जो कि इसको आपको इस तरह के डेटा पे आपको एक क्लासिफायर दे दे, एक रिप्रेजेंटेशन दे दे. दिस इज कॉल्ड regression model, where So the shape of regression model is this one when you plot logistic regression, where it gives, or for example, if you plot this linear regression model, if these points are like here, then these points are undecided and undecided ones. While linear regression give you full representation till infinity. Okay.